So my name's Larry Selby. I did one of the tips and tricks a couple of weeks ago. I'm a solutions consultant for Siemens. I've been working in Polarion and Siemens almost 5 years. So that's my background. So today we're going to be talking about risk management, and I was the one that suggested this topic to the organizers, which seemed like a great idea at the time. But then I sat down and I thought about it, and I said, okay, what am I going to present? So I thought about it, and like I said, it's a very broad topic and it's a very deep topic. So what does that mean? It means that every different industry has their own particular regulating bodies and their regulating standards that affect how they address risk and how they perceive risk and how they deal with it, right? And so within the automotive industry, for example, and the medical device industry and the aerospace industry, they're all different standards, and so they affect how all the different verticals address it. The other thing is within different companies, and I've been working mostly in the medical device vertical for the last couple of years, but without fail, from each company to each company, how they manage it is different, right? So the different P1s, P2s, P3s, or severities, occurrence detections, and how you calculate risk priority levels or numbers. And if this is A through D or 1 through 9, and then it's 9 a high level or is 1 a high level, it's all different, right? And what are the algorithms that you use to calculate this, and the colors and all that stuff. So the point of that being simply that our goal here is to provide a starting point with our project templates that hopefully can get you as far as 90% there. And, you know, maybe it is that you calculate your risk priority level a little bit differently, so you have to configure it differently, or the configuration of the work items and the relationships is a little different, okay? So the other thing to say is that spreadsheets still dominate, is my perception. Even in companies that I've seen, that I've talked to, that have successfully deployed risk management and test management in a product like Polarion, a lot of them still were doing their risk management and their FMEA analysis in spreadsheets that look something like this, okay? So you have a row, and this could be your risk, and you have a failure mode, effect of the failure mode, and here's your severity, your occurrence and detection, and your RPN is the multiplication of these three different fields, and then what's your recommended action and who's responsible, and a lot of companies track it in spreadsheets still to this day. So a couple things about spreadsheets. So I think there are a number of advantages to spreadsheets. Number one, they're ubiquitous, right? Just about everybody has Excel. Number two, there are recognized standards. So it may be that in your methods and procedures, you've called out that you have to do your risk analysis, and when you reach a certain milestone or you've released a product, you need to go ahead and take a version of this and archive it somewhere and have it available to your regulatory bodies to pass potential audits. Or it may just be an internal quality M&P. So there's that, and they're easy to use, right? You click on a cell, and you can easily edit the stuff. And you can set up equations editor to automatically calculate this. You can do conditional formatting to set up the colors. So they're a powerful tool. But the drawbacks and the advantages of using a tool like Polarion is the same for risk management as it is for requirements management and for test management. Namely, number one is really the single source of truth. When you have something like this, managing the versioning of it and collaboration between all the different stakeholders is something that becomes difficult. And then obviously the potential effects of failure, updating something that wasn't the latest version, is potentially, you know, a big risk in and of itself, right? When you're dealing with implantable devices in medical or cars or planes or things like that. So the other thing is, you know, real-time traceability, reporting, collaboration, audit history and control, yeah, things like that. So being able to facilitate reuse are some of the benefits. So within medical device, I would say risk management, requirements management, test management are the three-legged stool. And a lot of times where our patients, not patients, our organizations that we work for, the differentiator really, where they derive some of their most value is in the risk management. So what are we going to be discussing today? So basic topics. Topics are basic FMEA analysis, and this is in the out-of-the-box systems V model template that you have here. And this is will be demonstrated in the Drive Pilot demo project that I have here. That is part of the standard install of Polarion. Then we're going to be talking about a project template, ISO 26262, which was designed for the automotive industry. And then we're talking about our intelligent design control template, which is in medical device. And so in order of complexity of the project templates and their risk approach, this would be simple, more complex, and more complex yet, okay? So let's dive into this. So when you might notice, first of all, I'm using Polarion 2020. This was released, I don't know, 6 weeks or so ago. It underwent a UI refresh. And when you install it, if I open the projects and groups here, you get the option to install these demo projects. And Drive Pilot Demo Project is a project that's based on the Systems V model project, and it contains demo data. And I mentioned this, so if you want to go ahead and play around with what I showed you here today, you know that it's freely accessible to you. So I'm going to open up this risks folder here, or risk space, and we're going to determine, all right, how do we do risk analysis that's built into this template? So this is some of the process guidance and reporting that's built into the template. And this has been updated in the last year or so, and I'm a big fan of this. Building out the processes and the tool mentors and the process guidance into the tool, I think is really something which is best practice, which will pay itself over many times if you implement Polarion and you do this. So what are the inputs to the process? In this case, they are the requirements. The system requirements and the software requirements. These are grouped in specifications, which we call live docs. So I'm going to right click and open on one of these, the system requirement specification. And I'm going to assume most of you know what a live doc is, but in short, it has a feel like a Word doc or a Google doc, and it's a place for you to author and collect your work items, your requirements, your test specifications, your risk specifications in a container, a document-like container. So let us look at these first two system requirements, because these are what we're going to be working with. The vehicle must have a heads-up display feature, and the heads-up display shall flash yellow or red, okay? And these are the two requirements that we're going to determine the risk associated with these. Now, the output are these work items that we've created called risks, okay? And these are grouped in a requirement specification. So I'm going to go ahead and open that one. And this is where you can create risks that are associated with your requirements and link them and have them show up in the reports and the coverage analysis and traceability. And you'll see that shortly, okay? Now, before I step through this workflow, I want to open up this how-to, and this is another common feature in our templates. So it gives you yet more process guidance. And this tells you how you go and step through an FMEA analysis. And the first step is to identify your potential risks. And then now steps 2, 3, and 4 are how I classify them. So the severity is rated on a scale of 1 through 10, with 1 being the lowest and 10 being the highest. And it's the same thing for the likelihood of occurrence, and the likelihood of detection is 1 through 10. And the RPN is simply the multiplicative product of those 3 fields. Okay, so we go here, and so the first step is to analyze your requirements, to edit your risk specification to create new risks, and to link these to your requirements. So let's go ahead in here and create a risk associated with the heads-up display. So let's say drive pilot fails when HUD is activated. So let's label this as a risk. And now I'm going to create a link, and I'm going to say this risk assesses this first and the second heads-up display requirement. And I'm going to go back here and save this. And then if you notice here, I now have this new risk artifact or work item that's linked to these 2 requirements. Okay, so let's continue to step through this. And you can see, all right, now we can do a coverage analysis and determine what requirements have risk coverage. So if you scroll down here and you see, okay, this first one, this one has a coverage or this requirement, system requirement, and it has a task that mitigates this risk, but yet it's flagged because the task is unresolved, is in an unresolved state. And again, for those of you that are familiar with Polarion, I'm not gonna click all these links, but we have easy drill down capabilities, so you could click on this and traverse this and see the content of each of these artifacts and all the link relationships. And we scroll down to the bottom, you can see, okay, these are the 2 ones that we created. This is the new risk that's associated with these 2 HUD or heads-up display requirements. Okay, so now we want to classify this risk that we created, this new risk. So we're going to go and open this FMEA worksheet. And this is your view that looks a lot like your spreadsheet. And the goal is to make it as easy to edit this risk as you would in a spreadsheet, cells in a spreadsheet. So I'm going to click on it, and this pops open the sidebar for editing. So I'm going to say the detection is 1, the occurrence is 2, the severity is 3, the potential causes is a sensor failure, and the recommended action is, I don't know, fix sensor. Click Save here, and it updates this display. So you can easily use this worksheet to edit your risks just like you would in an FMEA spreadsheet. And though we try to encourage people to work within Polarion, we think there's a lot of benefits to that. We understand that, as I said earlier, Excel is still a prevalent tool. And so maybe it is that you've reached a certain point or milestone when you've completed this analysis, or maybe you have stakeholders that you want to collaborate with and you want to round trip this to Excel and share it, okay? So what you would then do is you would open this Excel as a table, and then you would simply click Export, and we have a out-of-the-box FMEA worksheet configuration, and this allows you to, it pre-specifies the fields that you want to make available on the export. You can click these to make them editable in Excel or not, and then you would just click OK, and then you have your export to Excel. So I could then open up this worksheet, and let me open it, and here it is. right? So then your various stakeholders could go in here and let's say, you know, fill this out further or modify it and then import it back into Polarion, or you could archive this and save it for a regulatory body when you have an audit. Okay, we're almost done. So the purpose of the FMEA analysis is not just to uncover the risks, but to determine that you've mitigated those risks, right? So we could use this risk mitigation task coverage report to go ahead and start to do that. So you can see, all right, we have 3 risks, only one of them is mitigated. So we could easily go ahead and say, all right, we want to mitigate this drive pilot fails when heads-up display is activated. Click on it, and then using just basic Polarion, I could then create a mitigating task, and I could say design new sensor. And I could assign that to myself with the highest priority. So that completes the loop, and now you have coverage of this one as well. So let me find my sports sheet. Okay, so let's talk about this a little bit. So we've worked within Polarion. We've effectively replaced the FMEA worksheet. We have traceability. We have reporting. There's some other things in here that I didn't talk about, which was workflow built into the risk artifact such that it makes sure that before it can be reviewed or approved, you must have taken actions to show that it was mitigated. You have to show that the new residual risk has been analyzed and things like that, okay? There are a number of different improvements or things that you may wish to do, you know, to extend on this, right? And this is some of the stuff we've done in the 26262 and especially in the med device template. So maybe you want to see that the mitigations to some of these risks could be that there was an incorrect label that was applied or incorrect training, or it could be that you need to specify a new design requirement, or maybe you need to specify a new design requirement and you need to show that it's been successfully tested, and you need to have a link or association to that executed test case, right? And so there are different ways to expand on this, but this is just a very simple, relatively simple FMEA application within your out-of-the-box systems fee model template. Okay, so I'm going to close some of these windows, and we're going to move along and go to the next topic, which is 26262. And I see we're moving along in time, so I'm going to speed this up. So I switched to a different project that has this template with some data instantiated. I want to say a couple things about it. First of all, we're doing a lot of work in Siemens in this area, ISO 26262. We're going to be updating this template to update the reporting and provide new functionality. And then perhaps even more exciting is that we're working with a business partner that's going to expand on this template and do things like have questionnaires that are integrated with the template to help you identify all your various hazards, classify them, and determine your ASO levels and your associated safety goals and functional safety requirements, okay? So as time is of the essence, I'm just going to really quickly talk about the framework here. What we've built into this project, or I should say configured, are these hazard work items. And based on the fields that you populate, and I won't get into the how-to here, but you know, the occurrence, detection, severity, or the equivalent of those, it automatically calculates the ASO classification. And then when you create safety goals, which are children of these hazards, they will then inherit that ASO classification. You can then define safety requirements, and then you could then decompose these into requirements that satisfy these safety requirements and test cases that verify and validate that you've successfully executed or implemented those requirements, okay, and then mitigated these hazards. So that's the basics of the 26262 template, okay. The other thing I want to point out is if you look on Polarion extensions portal, so if you Google Polarion extensions, this is the template that's available. And as I said, there will be an update, I think, soon. I can't give you a date, but it will be soon. And this is the intelligent design control for medical device template. And it will be available soon as it is available, sorry. And these are free for download. Okay, so let's talk about medical device development. So before I get into this, I want to give a plug for Lunch with Larry series on YouTube. And this is not me, this is my colleague, Larry Sampson. He's a medical device expert, and he's done a series of master classes and webinars. And this one here on risk management, 36 minutes, this is going to get into what we're covering in 4 minutes or 5 minutes. It's excellent. So if you're at all interested in this, I would recommend that you go to YouTube, Google Lunch with Larry. So let me just collapse this and then quickly talk about this diagram here. So in medical device development, in accordance with ISO 14971 specification, the FDA requires the manufacturers to develop a risk report, which is this box here in this diagram, that does a risk analysis from an end user, that is a patient or a clinician perspective, and what are the harms and hazards that they're exposed to, and how are they mitigated, and what's the residual risk, okay? So we've built that into what's known as a rack chart. So I'm gonna show that to you, and there's a lot of cool functionality that we've built in to make it very powerful, yet approaching the ease of editability of an Excel spreadsheet. Then furthermore, the model is that these user needs then can flow into different hierarchies of FMEAs. So the user needs are inputs to the use FMEA, and then the outputs to the use FMEA are the system requirements that are the inputs to the system's FMEA, and so forth. And then they flow down. And there's some really powerful things that we can do with the reporting when, for example, you're in the design FMEA, you know the severity of your risks because they're ultimately traced all the way up to the harms and hazards that are in the rack chart. So rather than talk more about that, let's get into the reporting. I'm sorry. Open this project here. Okay, so here's our med device design control project, and this is design control for an IV bag, okay? And so if I look at the risk management file folder and the rack chart here, now I get the rack chart. So you can see that I have harms and hazards, and let me just filter on this. So I'm looking just at these first two columns, so I'm going to go 9329, and let's take a look at this. So I've got a harm, which is temporary discomfort, and I've got two different hazardous situations that are associated with it. One is that the bag was damaged, and then the other is that you have patient anxiety, right? And because these are two different unique combinations of the harm and the hazard, you get a different risk record, okay, which makes sense because these could have different severities, they could have different probability of occurrences, they have different risk profiles. In fact, we've determined that this one is not essential performance, so it doesn't need to be further analyzed, right? So if you look across the row here, you can see, okay, what's the mitigation or control to this? And I scroll over, and when I click on the cell, I get the work item. And so this is a user need that mitigates this hazardous situation. And then furthermore, when I want to go and populate all this stuff, okay, what's the severity? You know, without these pop-ups, it becomes difficult because the severity is associated with the harm, The probability of occurrence is associated with the hazardous situation, but we simplify that all for you by making it available just so that when you click on it, you get the work items and you can edit these fields. And then it will then automatically calculate the risk profile, and there you go, okay? The other thing that's really powerful about this report here is we've built a lot of UI functionality. So if I wanted to create another mitigation or control to this risk, I would just click on this create button, it would create it. And then furthermore here, let's say this risk record here, or this harm is a heart attack. Let's say I want to create a new risk record, which is that the patient anxiety is associated or causes a heart attack. I would just save that, and it understands the link relationships between these two, okay? And it would create a new risk record. And then furthermore, it's smart enough to know, okay, if I want to link a user need to a risk record, there's no link role for that, right? So it's a very intelligent report and designed for you to be able to do work, an interactive report. Okay, so our last topic, we're going to get into the DFMEA. And what I'm going to show you here is, okay.
Larry,
yes.
we're running up on the clock here. We got a little over a minute left, and so I don't know how quickly you can.
All right, so let's just talk about this 1 second here. So here's our DFMEA, and looks like a standard FMEA, but the one thing I wanted to highlight here, and it has the same UI functionality as the rack chart, but as I'm down here in the design requirements and analyzing my DFMEA, because of its traceability up to the user needs and harms and hazards, when I'm analyzing this risk, I automatically know what's the severity, right? So I'm understanding how important it is for me to mitigate this risk. So this design requirement might have been associated with the heart attack, whereas this one might have been associated with the patient anxiety. So therefore, I know that this design specification, which satisfies this requirement here, is a critical or essential design characteristic, whereas this one may not be. Okay, so that is all that I have, and turn it back to Gary.
Thanks, Larry. I know you were trying to cover quite a bit of information in a very short period of time, so I appreciate that, and I appreciate everybody for sticking around. So, okay, well, feel free if you guys have any questions, reach out to us via email, and we'll be glad to answer them. Appreciate everybody's time today. Thank you, Larry, for your time, and I think that will wrap this session up.